Algebra 1, Lessons 17 and 18. Lesson 17 is all about translating between words and algebraic expressions so that when we have those word problems, we can know what operation to use. So if we look at all of these different words that we have here, we want to put them in these buckets: addition, subtraction, multiplication, and division. These are common words that we see in word problems. So let's put them in there. Quotient, well, that's talking about division. Plus, that's talking about addition. Divided by, well, that even has the word divided in it, so it's division. Times is multiplication. Difference, we're talking about subtraction. Product, we're talking about multiplication. That's the product, so a factor times a factor is a product. Minus, well, that's a subtraction sign. If we say something is 9 less than x, then we're talking about subtraction. The sum is addition. In all, that's oftentimes talking about addition. And equal groups is often talking about division. Okay? These are common words that you can use to talk about different equations, but also see in word problems to help you. Write an expression for each phrase. So, y increased by 12. Product of x and 4. And 8 less than the quotient of m and 15. And lastly, James is 6 years younger than Lydia, who is x years old. Write an expression that shows James's age. Let's start with y increased by 12. Well, if we have y and we are increasing, that means we're adding 12. Okay. The product of x and 4, well, that is multiplication, so we are going to say times, and we always want to put the 4, our coefficient, first. So 4x. 8 less than the quotient of m and 15. Well, if it's 8 less, then we are taking away 8 from something. The quotient of m and 15. Well, if it's a quotient, we're dividing, and it tells us the order. The m is the numerator, 15 is denominator. And lastly, James is 6 years younger than Lydia, who is x years old. So we have Lydia's age of x, and we're taking away 6. He's 6 years younger. So we would show that as x minus 6. All right, let's look at some some expressions and turn them into some words. M plus 7. Well, we could say something like m increased by 7, 7 added to m. For 5n, we could say the product of 5 and n, or 5 multiplied by n. 7 or y minus 9, we could say 9 less than y, or 9 or y decreased by 9. X and 3, the quotient of x and 3, x divided by 3, any of those. And lastly, for this long one here, there's lots of ways to say it. We could say the product of 18 and the quotient of 1 and 2, 27 less than 27. Okay? Or 27 decreased by 1/2, 27 decreased by the product of 1/2 and 18. Or there's so many different ways to say it. Okay? Let's look at this one. Jane is saving money to buy a car. She has X dollars saved and is saving Y dollars per week. Write an expression to represent the total amount of money she will have saved after 52 weeks. Well, she already has X dollars saved, and we're adding to that a certain amount per week. So if we have 52 weeks of that amount, we would say that we have X plus 52Y. All right, that's actually the end of the lesson. If you want some more extra practice, you can look at these and try these out. But let's go on to lesson 18, combining like terms. So, a couple things with like terms. First, to be able to have a like term, we need to have the same variable with the same exponent. And what I mean by that is if we have x squared y. For it to be a like term, I need to have exactly x and y in this term with x having an exponent of 2. It doesn't matter if we have different coefficients like 2x squared, negative 3x squared y, or even if we have them in different order like 5yx squared. Those are all like terms. But once we get into the area of something like 10x squared y squared, even though we have the same variable x and y, and we have the same exponent of 2 on the x, y is different because it has an exponent of 2. So this one is not a like term. But we could say these are like terms, and we could add them up to say 2 and take away 3, that's a negative 1, plus 5 is a 4x squared y. Okay, so just a little bit about those like terms. Looking at this one that we have on the board, we have 5 times the quantity z plus 2z minus 4z. Now there's a couple ways to do this. First, we could distribute this 5 to the z and the 2z to have 5z plus 2z minus 4z. So we can add together 5z and 2z is 7z, 7z, minus 4z, so altogether we have 3z. Remember that when we're adding and subtracting like terms, the actual term, like the variables and exponents, don't change, just those coefficients are added together. And so we get a 3z at the end. The other way that we can think about this is factoring out something so that we can add together other parts of it, like the coefficients. So in this case, we could factor out an x so that we have 5 plus 7. Well, 5 plus 7 is 12 multiplied by x. I bring this up because it's helpful for the future to start thinking in terms of factoring. 6y minus 3a plus 4yx. Well, when we look at each of these, here we have just one y, here we have an a, here we have a y times an x. Are any of these like terms? And you should think to yourself, no, because we have all different things in each of these terms. But maybe this one could have some like terms. Negative 4y minus a negative 3y plus 5y. And we would say yes, these are like terms because we each of them has a y with an exponent of 1. So we can simplify to say negative 4y minus a negative 3. Well, minus a negative 3 is just adding a 3y plus 5y. So when we look at this, negative 4y plus 3y, that's a negative y, plus 5y is 4y. So we have a total of 4y. Remember, don't change the actual variable, we just work with those coefficients. Let's get into some more challenging ones, okay? Let's do these. So let's distribute that 4, and we get 12c, and we get a minus 16, plus 2 minus 4c. Well, if we look, some of these terms have c's, some of them do not. Well, the ones that have c's, I'm going to group together. So we have 12c minus 4c, and then we have my minus 16 plus 2. Well, I can combine these because they are like terms. They both have c, so that I have 8c. And these I can combine to be minus 14. The question is, can I combine 8c and negative 14? No, they have to stay like that because they are not like terms. 14 does not have a c, so I leave it as that. This one here, we distribute, and we get 3a plus 12 plus b minus 5 plus 2b. And let's move things around to be with their similar terms. 3a, unfortunately, it doesn't have a friend. There's nothing else that just has an a in it, so we leave it alone. But I can move the 12 and the negative 5 to be close to each other because both of those don't have variables. And I can move the b and the 2b next to each other. So we can say we have 3a plus 7 plus 3b. And I can't do anything more than that. That's all that we get. That's it. Okay? If we look at something like this, we would say, what are my like terms? So I'm looking for things that have the same variable and the same exponent. And I see that my x to the fifth, those two are the same. And I have my y to the third and y to the third. So same variable, same exponent go together. So I have y to the third plus y to the third, and I have x to the fifth plus x to the fifth. Well, as you remember, each of these just has a 1 coefficient in front of them. So I'm adding 1y to the third plus 1y to the third is 2y to the third, and 2x to the fifth. Nothing more can be simplified because those are two different terms. All right, a little bit more complicated. 3k squared minus 2k squared plus 4k squared plus 2kx to the fourth plus kx to the fourth. We have two terms, right? Two unique terms, k squareds and kx to the fourths. So let's add those k squareds. 3 minus 2 is 1k squared plus 4k squared, which is 5k squared. And then we have 2k squared plus 1k squared is 3kx to the fourth, kx to the fourth, plus, so we have 5k squared plus 3kx to the fourth. And that's all we can do, because those are not like terms. Our final example that we'll do this one. The Olympics uses a standard size pool for swimming competitions. Find the perimeter of an Olympic size swimming pool if the length is 10x and the width is 5x. Then we'll plug in 5 for our x to figure what it is in meters. So if we draw an example of this, what they are saying is the width is 5x, the length is 10x. Well, to get perimeter, I need my 5x plus 10x, and then we need another 5x and another 10x to get all the way around. So another 5x and 10x. Thankfully, these are like terms. So I can add together 5 and 10 and 5 and 10 and get 30x. So when I go to put it in as meters, I can say perimeter is 30 times 5. And we will find that this is 150 meters all the way around. Well, I hope this was helpful for homework and for studying.